Hello everyone, my name is Angelina Jolie and my NPM is 2132018. So in this video, I will explain how HTTP, HTTPS and DNS protocols work in Wireshark. Okay, the first protocol that I will explain is HTTP. HTTP stands for Hypertext Transfer Protocol. HTTP is the foundation of the World Wide Web and is used to load web pages using hypertext links. HTTP is an application layer protocol designed to transfer information between network devices and runs on top of other layers of the network protocol stack. A typical flow over HTTP involves a client machine making a request to a server, which the server will send a response message back. HTTP clients generally use Transmission Control Protocol or TCP connections to communicate with the server. In here, I will explain how HTTP works. First, open the Wireshark app and start to capture the data. After that, we go to the browser. In this case, I will use Chrome. For HTTP, I will access the mysql.phi-integration.com website. When the website shows and stops to load, we go back to the Wireshark again. In here, we can see the data transaction have happened. I will click this red button to stop capturing packet. To find the HTTP packet, I will type HTTP in the display filter and click Next. As we know in the computer network, each device is identified by IP address. This source here indicates the client, which is my laptop IP address. When we type a URL in the browser, just like what we did before, in order to get the website IP address, the browser uses a DNS resolver to map the domain to IP address. The DNS resolver will give us IP address for our requested website. Just like in here, the destination. We can see this is my SQL website IP address. We can also check them in the command prompt. We can see my laptop IP address is the same with this IP in the command prompt. So did the website IP address. And once the browser gets the IP address of the server computer, it will send the HTTP request to the server, just like what we see in this packet. Okay, so what is in the HTTP request? HTTP request basically contains of request line and header just like this. In the request line of HTTP request, we will have a text like this. The first word is the HTTP method. Method is a command that tells the server what to do, like get in this case. Get method is used to retrieve information from the server. The other most used method is post, which is used to send data to the server. And then there are head, put, delete, connect, and options. And this is the function or description of each method. Next, there is the path resource or URL, which is SQL/membuat trigger di MySQL. After that, it shows the protocol and its version. Here is HTTP protocol and the version is 1.1. Next, we will move on to the header. There is a host which specifies the domain name just like what we see here. Next information is connection, which have value like keep alive. It indicates the connection is persistent and not closed. Then there is user agent. For most web browser, it shows Mozilla and operating system, which is Windows. Next, there are also accept encoding, and accept language that tells what language the client understands. In this case, it is English. Other thing that is important to know is HTTP uses port 80 by default. Okay, so that is everything in the HTTP request. And now this entire request will go to the server. After the server understands the request, it will process using various server-side scripting language like PHP, Java, ASP, and etc. Then the server will send it back to the client via HTTP response, just like this. This is the HTTP response that the server sent. And what is in the HTTP response? HTTP response contains status line that has protocol with version number and status code. In here, we can see the protocol is HTTP with version 1.1, and the status code is 304, that means not modified. Status code is 3-digit integer where first digit of status code defines the class of response. And these are some of the most used status codes. You can see this is the meaning or description of each status code. Okay, we will go back here. This is the header of HTTP response. In here, we can see there are X robot tag, last modified date, e-tag, and server. Sometimes the HTTP response header actually consists of other things, such like cache control, connection, content encoding, content length, content type, and expires. After this type of header information, usually there will be message body that containing whole HTML for our web page in response. And yeah, that is everything in the HTTP response. So this entire response will come back to the client, and at last, when the browser gets the response, it understands the response and render it. After that, we can see the web page that we want to access, just like this MySQL website. Hypertext Transfer Protocol Secure, or HTTPS, is the secure version of HTTP. HTTPS uses port 443 by default. HTTPS uses an encryption protocol to encrypt communications. The protocol is called Transport Layer Security, or TLS, although formerly it was known as Secure Sockets Layer, or SSL. This TLS handshake protocol is basically used between a web client and a web server to establish trust and then negotiate what a secret key should be used to encrypt and decrypt the conversation. With the protocol in place, an eavesdropper can only see the connection endpoints, but cannot read or modify any of the actual data. And here is the process how a client and a server use the handshake protocol to negotiate and exchange data securely. For HTTPS, I will access the shopee.co.id website. Then we click enter. Next, I will go back to the Wireshark. Then we stop to capture the packet. In the display filter, I will type TLS and click enter. So, after the three-way handshake protocol is done, which consists of SYN plus acknowledge, and acknowledge, the clients here, which is my laptop, will send to server a client hello message. It lists of information such as the SSL or TLS version, the cryptographic algorithm, and the data conversion method that is supported by the client, just like what we see here. Then the server responds with a server hello message like here that contains cryptographic algorithm chosen by the server from the list provided by the client, and it will send the session ID too. The server also sends its digital certificate, its public key, and server hello done. Same like what we see here, certificate, server key exchange, and server hello done. The next step, the client will contact the server CA or certificate authority and verify the server's digital certificate, thus confirming the authenticity of the web server. This step is basically establishing trust on the web server. Next step is the client key exchange. Once the client trusts the web server, the client will send a shared secret key to be used in the following conversation. The secret key is encrypted with the server public key. The clients also send a finished message, which is encrypted with the secret key too, indicating that the client part of the handshake is complete. As we can see here, there are chain cyberspec and encrypted handshake message. And then the next step, the server will respond to the client with a finished message, which is encrypted with a secret key, indicating that the server part of the handshake is complete too. As we see here, there are new session ticket, chain cyberspec, and encrypted handshake message. Okay, once this handshake is done, the client and server can now exchange messages that are symmetrically encrypted with a shared secret key. And yeah, that is basically everything about how HTTPS works. The domain name system, or DNS, is a fundamental component of modern networking that translates between human-readable domain names and the underlying Internet Protocol, or IP addresses, the connected devices use to talk to each other. For the DNS, I will search the lazada.com website. Then we go back to the Wireshark app and click Stop Capturing Packet. In the display filter, I will type DNS and click Enter. So we will take a look at this query. We can see in this query, we are actually asking for the IP of lazada.com domain. In here, we can see the transaction ID is 0x7A03. And we can see up here in packet 296, which is the response to the query on packet 262. It also has the same transaction ID as the query before. And this is how we can match up the query to the response. Or we can just look at the arrow on the left here. we can see there are two arrows that are connected with a line. That means they are the corresponding query and response. And actually, this transaction ID is useful because if you see a number of response or queries with the same transaction ID over and over again, we may have a look on the network. So that could point to a problem with the spanning tree, for example. Okay, we will look back at this query again. In the flag here, we can see there is 0 bit, that means this is a query message. And then in here we can see recursion desired, do query recursively. And what does it mean? It means client, which is internet browser, requests that the DNS server to perform recursion for them by setting a recursion desire flag in the request packet. So when we type in lazada.com in our web browser, and if our web browser or operating system cannot find the IP address in its own cache memory, it will send the query to the next level to what is called with the resolver server. The resolver server is basically your ISP or internet service provider. When the resolver receives the query, it will check its own cache memory to find an IP address for lazada.com. And if it cannot find it, it will send the query to the next level, which is the root server. The root server is the top or the root of a DNS hierarchy. Each set of these root servers have their own unique IP address. So when the root server receives the query, the root server is not going to know what the IP address is, but the root server will direct the resolver to the TLD or top-level domain server for the .com domain. When a TLD server receives the query for the IP address for lazada.com, the TLD server is not going to know what the IP address is, so the TLD will direct the resolver to the next and final level, which are the authoritative name servers. The authoritative name server are responsible for knowing everything about the domain, which includes the IP address. They are the final authority. So when the authoritative name server receives the query from the resolver, the name server will respond with the website IP address. And finally, the resolver will tell our computer the IP address for lazada.com. As we can see in this response packet, in here we can see the 1 bit, which means this is a response message. In here we can also see recursion available. It means that yes, the server can do the recursion successfully. Because of that, our computer can now retrieve the Lazada web page. And we can see in here, these are the response for the queries. And there are 7 of them. Just like they are listed in here. For additional information, we can see there is an A here, which means this is DNS A record that translates domain into IPv4 address, just like this. And it is important to note that once the resolver receives the IP address, it will store it in its cache memory in case it receives another query for lazada.com. So it doesn't have to go through all those steps again. And that is basically everything about how DNS works. Okay, so that is all my explanation about how HTTP, HTTPS and DNS protocol work in Wireshark. I hope this video can be useful for you, and I'm sorry if there are any mistakes in this video. For the last, thank you for watching and goodbye.